Welcome again to the next part of section 12.9, dependent motion. So we will need to start with establishing a datum from fixed position for each object of interest, and also identify those segments of cable whose length remains unchanged during the motion. So if you want to do that, let's start by the datum. And for example, we can say that this point is fixed, and we can just say that this is SA. So this is the datum that is going to measure the length SA. And from here also, this is also fixed. We can shoot an arrow toward C, and we call this is SC. Now for the segment that doesn't change, we have this part that doesn't change. This part also doesn't change, actually all the way to the end. And we have also this part. This one is always there, it won't change. And whatever after is going to be measured as a length which is going to change as the motion is set. So as we said, we now ready to write down the chord equation, which is SA plus 2SC equals to L, which is constant. Why 2? Because we simply have two segments. That's segment number 1 and that's segment number 2. Now, we just need to differentiate with time. So we'll get VA equals to negative 2VC, which means if the cylinder is drawing in BC at 2 feet per second, that's it. That's the direction, 2 feet per second in this direction, then VC is positive. So VA is negative. Why? Because VC will move right here, but VA is going to move opposite to the direction of the datum. And for that, we would say that VA is simply going to be minus 2 multiplied by 2, which is equals to minus 4 feet per second. And that's it. Now let's have another example. In this example, we have two chords. This is chord number 1 in blue, and in red we have this chord, which is going to go like this all the way to the end. And for that, we will actually need to write two equations. So in this example, what we want to know what is the speed of block B. So VB is unknown. Now, what is known is VA. VA, which is the velocity of point A at the pulley, is being pulled down with a speed of VA equals to 8 feet per second. So we want to know what is the speed of block B. Find the speed of block B. Now I will start by establishing one datum. And this datum is going to be this line over here. This is the datum. And what I'm going to have is to define the lengths. So this is from here to here. This is going to be SB. And from here to here, this is going to be SC. And from here to here, this is going to be SA. And that's it. That's the first step. Now, after establishing the lengths as I did in the previous slide, this is SP, this is SC, this is SA, and this is the datum. What I need to do now is to write the chord equations, but we have actually two of them, which are already marked here as purple and green. But the lengths that are going to change, I'm going to mark them with two different colors, the red and blue. So for the red, I am actually going to have this one, this one, this one, and this one. And for the blue, I am going to have this one as well as this one. So let me write down the first equation in red, which is going to belong to this chord, this one, and this one. So if I write down those equations, it's going to be 2SA plus 2SC equals to L1, which is equals to constant. So let me make sure that you see what I see. We have SA1, SA1, so two of them is equals to 2SA. We have 2 of SC, and this is why we have 2. And this is, of course, the sum of these is equals to constant. For the next chord, which is in the blue, we have one length, which is SB. So this is SB plus this little segment. So this is SB, and this is the little segment over here. So that little segment is equal to what? Is equals to SB minus SC, which is equal to L2, which is equals to constant. So now what we can do, if you remember, when I was explaining the procedure in part number 1, I said that these two chord equation has to be related by a single parameter so that we can write down the two equations. This parameter is indeed SC. It is SC. So if I want to, what do I do? I just basically eliminate SC from the two equations. So what I will get 2 SA plus 4 SB equals to L1 plus 2 L2. So if I want to write this one in detail, let me quickly show you how I did this. So if we call this one equation number 1 and this one equation number 2, then from equation number 2, we are actually having SP plus SP minus SC, which is equals to L2, which gives me 2SP minus SC, which is S all over 2. So if I solve for SC, I will get 2SP minus L2. So what do? This is equation 3. So substitute 3 into 1. And what you are going to get? You're going to get 2SA plus 2 multiplied by 2SP minus L2, which is equal to L1. And you will then get 2SA plus 4SP minus 2L2, which is equals to L1, which means that you will get 2SA plus 4SP, which is equal to L1 plus L2, which is basically the same as this equation. Now, if I differentiate with respect to time, I should keep in mind that L1 and L2 are both constant, so what I will get 2VA plus 4VB equals to 0, which means that VB, which is the velocity I want, is equal to minus half VA. So this is going to be minus so this is going to be equal to minus 0.5 multiplied by 8, which is going to be minus 4 feet per second. So what matters over here is that if you look carefully to the sign, this is negative. And basically, we know that VA was moving downward, and it is positive. But VB will move upward, so it has to be negative, which is true. So this is the end of this section, and to summarize, we just learned what is the dependent motion. We also learned how to establish proper datum in different ways. We also learned how to write down the chord equation, taking into account that if you have multiple chords, this means that you have to have multiple equations and you need to know how to link them together. That's it. Thank you.